Okay, hello and good afternoon, year nines. How are we doing? Okay, so last week we looked at substitution when you substitute a number in place of a letter. Okay, and we didn't actually solve the equations, we just substituted them in and got an answer to the expression. This time we have equations. Okay, so it's equal to something. So 4x plus 2 equals 18. This time you have to figure out what would this x represent, what value would it be. So it's 4 times something plus 2 equals 18. And everyone has different ways to approach these, so feel free to use your own method. Some people can just look at it and just figure out what it is straight away. But I'll show you a method that will work for all of these types of examples. Okay, it's called a inverse method. So you do the inverse to what you're doing on one side of the equation. For example, if you're adding 2 at this side, you would take away 2 at this side. So that's the method we're going to look at. So 4x plus 2 equals 18. So you're left with 4x. You want to get rid of plus 2. So that will be equals 18 minus 2. Okay, so then you're going to be left with 4x is equal to 16. So that means 4 times something is 16. So one of those x's must be equal to 4. Okay, and you can check your answer. Put this 4 back in place of x at the start. So remember, when you've got a number and a letter, it's timesing. So 4 times 4, 16, plus 2 equals 18. So you know you're right. So with algebra, you can always check your answer and know if you're right or wrong. Okay, we'll look at the second example. This time it's 5y minus 7 equals 23. So using the inverse method, 5y, you have to get rid of minus 7. So to get rid of minus 7, the inverse is add 7. So that means it's 23 plus 7. Okay, so using your addition, you should know that 5y then is equal to 30. 5 times something is 30, so y must be equal to 6. Okay, hopefully I'm not going too fast. Pause the video if you need to. Okay, and the final example is a slightly trickier one, for the reason being that there will be a negative answer. Okay, so you have 3a plus 11 equals 2. So once again, you keep the 3a there, you get rid of plus 11, doing the opposite of it, or the inverse, will be minus 11. So 3a is equal to 2 minus 11. This is when you go into negative numbers. So you're starting off at positive 2, and you're taking away 11. So that means 3a is equal to negative 9. Okay, so that's the tricky little bit. So 3 times something is negative 9. So that must be 3 lots of negative 3. So a must be equal to, we will keep it lowercase a, that's equal to negative 3. So you can check your answer. 3 lots of negative 3 is negative 9. Negative 9 plus 11 is positive 2. Okay, hopefully that makes sense to you, and you will be able to work through that first worksheet at least.